I want to go back to expected value, and this is kind of the more main lesson here, but I want to tie it to things you know, or hopefully you know. One of them is GPAs. GPAs are a weighted grade. So you have a weight, and then you have a grade. And so the way we weight things, and is by credit hours. So maybe you get a B in a 5 credit class. Maybe you get an A in a 3 credit class, and maybe a 4 credit, you have a C, okay? And so you're only taking 12 credit hours, okay? All right, so the way we figure out GPAs is we weight it because some things are worth more than others. So a 5 credit class is worth more than a 3 credit or a 4 credit. And the grade, A's are 4.0s, B's are 3.0s, and a C is a 2.0. And what we do is a weighted grade. So we multiply, which is what? 15, 12, and 8. That's 20, 35, and we add. And those are called quality points. And then we divide by the weights here. 5, 6, 7, 8, what do we say, 12 credits? We divide by 12. So 35 divided by 12 would be this person's GPA just for that semester. They have a 2.92 basically, okay? All right. Weighted grades in a class are the same thing. So say you have a teacher that does, weighted grade. Say you have a teacher that says 70% of your grade is tests, 30% is quizzes, okay? And say you have a 90% average on your tests, and say on quizzes, maybe you don't take them as seriously, you only get a 70%. So you take the weight times the grade, which in that case, it's going to be 63% goes towards your final grade, and 30% of that is 21. And so you get what, an 84%. So you're going to get a B in that class. Even though you have A- average on all your tests, it's because your other stuff is at a C-. So this student, I would highly suggest like retaking quizzes, things like that, because, their test grades really aren't that bad. But these are example of weighted grade, GPAs and a weighted grade in a class. And that's really what an expected value is. It's kind of a weight. So I usually make these sideways, and in weighted grades, if you're like, but Julie, you didn't divide by the total. Well, when you're doing a percent, these add up to 100%, which is 1. So dividing by 1 doesn't do anything. And that's why in expected value, we don't have to worry about it either, because probabilities always add up to 1. All right, so let's look at this. I like to do my chart a little backwards from here. I like to do probability on top and value on bottom. And again, probability is your probability, and the values like your X value. All right, so a symphony decides they're going to have da-da-da-da-da. They have that. They have 2 books. Okay, 2,000 tickets are sold. Okay, and how many? Someone's going to win a microwave oven, so they have a 1 in 2,000 chance of winning a microwave oven. A dinner for 2, so 1 out of 2,000 chance of winning that. And 2 books worth $20 each. So that's what, 2 chances out of 2,000. And I need a little more space. I should have written smaller. I'll put another sticky note there. And then this is your probability of winning. So there also should be a probability of losing, okay? So, because this is like a game. So the probability, what is that? 1, 2, 3, 4. So 2,000 minus 4, if you can't do that in your head, you can use a calculator, is 1,996 out of 2,000. And these should add up to 2,000. Like this should be equal to 2,000 because 100% probability. These should add up to 1. 2,000 out of 2,000 is 1, okay? Now the value is if you win, if you win, it is your net win, meaning the value, the true value of what you won. Well, you don't really win $400 because what'd you do? You paid $1. You're only really winning $3.99. If you win the dinner for 2, it's worth $80, but you paid $1 to win it. So you really only won, these are positive, you won $79. And the 2 books worth $20 each, they really only win $19. Okay, so that's your net win if you win. Now, what if you lose? Because that's the other possibility. Well, losing is going to be negative. And what are you going to lose? Well, most likely you're going to lose $1 because you're playing this game that's $1. And that's your probability of losing that $1. Okay, so what does the formula say? It says multiply, 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 and add up. Kind of like what we did when we did these guys. We multiplied, multiplied, multiply, add up. All right, so we're going to do this up and down. I just like this better. So we're going to multiply multiply, multiply, and multiply. And then we're going to add those up. All right, so for some reason, my computer glitched there a little bit. So I'm going to go back and type that stuff in. So I'm going to pause for a second, but I'm going to put this in parentheses times that, plus this in parentheses times that, this in parentheses times that, and this in parentheses times that. And actually, I think I still have it stored in my computer. So I end up with a negative 74 cents, okay? And what that means is on average, whoever goes to this symphony and does this raffle all the time, on average, are going to lose 74 cents. Sometimes they'll win. They might win a book, right? Or they might win the microwave. But on average, they're going to lose $1 all the time. But this is like over 30, 40 years. Maybe they do it 100 years, or, you know, that's what expected value it is. It's kind of an average. And if you're like, well, why don't you have to divide by 1? Well, the probabilities add up to 100%. So dividing by 1, you know, doesn't really do anything. All right, let's try this next problem. Okay, so usually a lot of times there's a negative in these if it's a game of some sort, okay? So I'm going to do probability. I like to do it this way, and value. My math lab might do it the opposite, but it's the same idea. All right, so a local club, let's see, they're going to invest to host a baseball game. They expect to sell tickets. If it rains on the game, they won't sell any tickets and they'll lose money. The weather for that day is 20% chance of rain. Okay, so I like to do my probabilities first. And so I know they have to add up to 100%, win or lose, right? Like it's going to be either way. All right, so in this case, this is it rains. So the other option is what? It doesn't rain. And together those should add up to 100%, okay? So in this case, you know, you got to kind of think about what raining means. Raining is kind of like losing because they lose, you know, obviously the money if they don't do it. And then when is it rains. Okay. And again, remember, this is the net loss and this is the net win, right? Like the gain. Okay. So let's read it. They plan to invest $10,000. Okay. So it's going to cost them $10,000. And they sell tickets worth $15,000. Okay. So if they sell tickets worth $15,000, they really don't make $15,000 because it costs $10 to, or $10,000 to host it. So their net win, if it happens, is just $5,000 because they still have to pay for all those expenses, okay? If they lose, they actually, spent $10,000 on this thing. So they're going to lose negative $10,000. Okay, so this is the net loss. If it rains, they're going to lose all $10,000 they invested. If it wins, yeah, they make that, but that's not profit. That's how much they sell in tickets. That's revenue. They still have to subtract that. All right, so again, probability times value, get an answer, plus probability times value, get an answer, and then we'll see what we get. So if you type this in your calculator, okay, that is what, negative 2,000? And if you type that in your calculator, that's positive 4,000. So if you add that together, that's a net of 2,000. So that is the expected value, meaning on average, if they host this kind of baseball game all the time, on average, they are going to make, you know, $2,000, which I don't know if it's worth it. I would like a higher I'd like a little higher here for all the work, right? That doesn't, only gaining $5,000 on a $10,000 of expenses to, yeah, I don't know. This doesn't seem like a very good expected value if it's supposed to be a big fundraiser. So I'm not keen on that one. All right, I'm going to pause. I'm going to put a new problem up. Okay, this one's a little more straightforward, I think, than the last one. So we're trying to find the expected value. So I'm going to probability and value. And value's your X. Let's see, what do I know here? 1 out of every 50 is bad. Okay, so 1 out of 50 is faulty. And the only option is that it's good, right? You either have a faulty equipment or good. So this would be the rest of the 100%. So again, these have to add up to 100%. Suppose a company makes $3 profit. Now the word profit is net. That's what profit means, right? It is the net, what they get after expenses. So they might sell this for, say, you know, whatever, $30, but it costs them $27 to do everything. So they, you know, they net $3. Okay. So that is, so their net profit is $3. So that's good. Okay. So then we have to do like, what's their net loss basically? Well, let's see. They suffer a loss of 80. So they actually tell you what the net loss is. They don't, you know, say it's $83 and you have to deal with, no, it's saying the net loss. So this is negative 80. All right, so we're going to take that and that. We're going to multiply and add, just like a weighted grade or anything else. Okay, so, and again, I'm going to put these in parentheses. Fractions are always good in parentheses. And then you can just do this number plus this number all in one big thing as long as you use fractions, percentage, parentheses around your fractions. So like 49 over 50 end of parenthesis and then times 3. You want to make sure that's in there and make sure you have a negative. All right, $1.34. All right. All right, so what does that mean? Okay, so check whether the company okay, so the expected value is positive, okay? So they make a profit, right? So on average, because they have to return some, on average, they really don't make $3. On average, they make $1.34. Now, I can tell you what some companies do, like Amazon. If it's going to cost $80, they're going to say keep it and we'll mail you a new one. Like, we've had big ticket items before, like a vanity that was like in the thousands of dollars and it was flawed. And to ship it back, the company was going to lose more money than giving us another one. So we just had to submit pictures of the damage and they're like, just keep it. And then they mailed us a new one because the loss to them was so high that it screwed up their expected value. So they're like, we're not even going to worry about the loss of $80. We're just going to send you another one. So, you know, some companies will do that, but this means on average, they're really making $1.34 because every once in a while they have to do that $80 thing, which is not fun. All right, let me look at another one, and hopefully you're getting the gist of these. Okay, this is a problem in your ebook on page 762, and you're supposed to compare site A to site B. So again, we're going to try to decide where to drill oil. So what you need to do is do the expected value for A, do the expected value for B, and then we're going to compare them. And I think in this problem they ask what the difference is, so we'll look at that. But pause the video, see if you can set up the charts. So you're going to have to set up 2 charts, one for site A, one for site B. Okay, I set up my charts. Finding oil, 20%. Remember, the rest of the 100% has to be the other one. So that would be 80% there. 10%, 100% minus that is 90%. Profit is net. Loss is net. Those words mean that. Profit means net. Loss means net. And so what you do is you take this times this plus this times this, enter, and I got a 8 for that. And that would be 8 million profit that they would make if they did this one. Probability times value, bring those down, and then add those results. And again, one should be negative because you're losing here. This one ends up negative, which would be really bad, right? That means you're losing on average that many $1 million, not good. And then on the question in the book, they're like, how far apart are these? So from, if you think of a number line, right, from a negative 4.1 all the way to 8, right, that's a, positive 4.1, another 8. So that's 12.1 million spread between the 2 answers, okay? So expected value can help you make decisions, like should you take out the insurance on your iPhone, should you not, on your fridge, plane insurance, things like that. I'm going to pause. I'm going to set up one more problem. Okay, here's a roulette wheel, all right, and notice they put 0 and 0, 0 on green, so it's a little tricky. Half are red, half are black, and they try to mess you up that a little way. So there are really 38 slots, 18 black, 18 red, but then they have a 0, 0, and a 0 slot that people tend to forget about, which kind of messes your probability up. All right, say that you want to land on a 7 on the wheel. You bet $1. Now, this is different because if you win, you actually get your $1 back and you win $35. All right, so we're going to set up this expected value and then look at it. Okay, so in this one, there really are 38 slots, and a 7 is one of them. So you have 1 chance out of 38 to win. Everything else is losing. Again, these have to add up to 100%. Now, if you didn't get your $1 back, you really would have only won, what, $34? But because you get your $1 back, that 35 is the net. You truly do win. Or if you think of like, well, I won 36, yeah, but then you have to pay the $1 back. You know what I mean? And so it's really 35. The net win is 35. The $1 is what you paid. That was your money to begin with. You really did win $35. It's not 34 because you got your $1 back, okay? And then losing, you lose $1. Again, multiply, 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 bring those down, and then add. And on average, you're going to lose a nickel. So if you're a gambler, not a really bad game to play. If you don't get your $1 back, that would be $34 because you would only really win 34.